I'm Mrs. Benoit, and you're going to learn about solving one-step equations.
And I'm Mr. Romanovich, and I will talk you through it. Here's what we know. We started with expressions. So here we have y minus 3 is an expression. X plus 3 is an expression. Why are they expressions? Because there is no equal sign. And we're going toward equations. So for equations, what we're going to have is that equal sign comes back. X plus 3 equals 6. But we're not just going to be doing it because we know x is 3. We're going to be solving this algebraically. So when we see something like y minus 3, we'll be able to solve it algebraically instead of just substituting 9 for y. How do we do that?
How do we do that?
Well, what we have to do first is remember to isolate the variable. Isolating the variable is key to solving things algebraically. So eventually what we want to find is that this x ends up by itself on one side or the other of the equal sign. And in order to do that, we have to keep both sides of the equation balanced. So when we see something like x plus 3 equals 6, to keep things balanced, whatever we do to one side, we have to do to the other. So if I subtract 3 here and subtract 3 here, I end up with x equals 3. 3 minus 3 is 0, leaving us just x. 6 minus 3 is 3. X equals 3. What helps us keep our balance? What helps us keep our balance? Well, what we're going to do is we're going to use a thing called the wall. And if I draw the wall here, I'm going to make a big vertical line and a big horizontal line. And then whatever I do on this side, I have to do on this side. So now when you see this, we have x plus 3. And on that side, I need to subtract 3. And to keep it equal, I subtract 3 on this side. Plus 3 minus 3 is 0. Do I need to write 0? That's the teacher wait time? You said no to yourself quietly? No, I don't need to write the 0, so I still have the x. Maintain the equals. 6 minus 3 is 3. That's how you do that algebraically. So we move down to here. If we're doing subtraction, here we have y minus 3 equals 4. So we'll build our wall. And if we've got to get a minus 3 out of here, we need to get 0 on this side. We use the additive inverse, or what some people call the opposite, and we're going to add 3. So if I add 3 to this side, negative 3 plus 3, or minus 3 plus 3 is 0. We need to add 3 to this side. And by doing that, we end up with y by itself and 7. Y equals 7. So here's an example. In this example, we have 7x equals 13. So first step, build my wall. Then as I look at it, I say, okay, just because the order's changed here, it doesn't change my thinking. I still want to take 7 away. I have to remember that's a positive 7. Then keep my equals. If I'm subtracting 7 here, I need to subtract 7 here. 7 plus 7 minus 7, 0. Leaves us with just the x and our equal sign. 13 minus 7 is 6. So we know that x equals 6. Not too tough. Then down here, whoa, what's happening here? Now the x is on the right, which is no big deal. We're still going to build our wall through the equal sign. Then we need to get this minus 8 off this side, or negative 8. So that's right. We're going to add 8. And if we add 8 to this side, we need to add 8 to that side. Equations don't like to be equal. Negative 8 plus 8 is 0, leaving us just x. 12 plus 8 is 20. X equals 20. Going back in here, the best thing about algebra is you can find out if you're right immediately. Take that value for x, put it back in your original equation. 20 minus 8 is 12. So, by tomorrow,
By tomorrow, we want to know if you did indeed learn how to solve algebraically. So we have 3 equations that we want you to practice using the wall to show your work. Y plus 6 equals 9, x minus 4 equals 7, and negative 6 equals x plus 4. Good luck.